For my next trick, we will prove proposition 4.38. However, there's a lot to unpack here, so we're going to break this one up into two videos because if I make a small mistake, I'm not redoing a 20-minute video. Anyway, let's go to reading the statement. So let V be an operator on a Hilbert space H. The following are equivalent. V is partially isometry, the adjoint of V is partially isometry, the product of V and its adjoint is a projection, and the product of the adjoint and V is a projection. Moreover, if V is a partial isometry, then V adjoint is a projection onto the range of V, and V adjoint V is a projection onto the initial space of V. Now, to start the proof, we are going to assume number one, so V is contractive is our first claim, and that follows from the fact that V is a partial isometry. So from this, we say for all F and H, I minus adjoint V F inner product F is equal to the inner product of F in itself minus V adjoint V F comma F, which again are just the norm squared of F and the norm squared of V of F, which, as this is a contractive map, must be greater than 0. So we get that I minus V adjoint V is a positive map. Now, they're a positive operator, sorry. It's the proper term. Now, since V is a partial isometry, if F is orthogonal to the kernel of V, then simply by the definition we get this. Yes? But this implies that the inner product I minus V star V F F is equal to 0. However, we know that the norm I minus V star V 1/2 F squared is equal to the inner product I minus V star V F comma F, which we've just shown as 0. Now, since this is a norm, we know it's positive. Since this is a norm, we know that it is a real number, and if it is the only function, the only vector that's norm is 0, this gives us that the inside must be 0, which we can obviously lose the 1/2 and just make this claim here. But this gives us directly that V star V of F is equal to F. So we get that V star V is a projection, because by Prop 414 we know V star V is positive, which by 4.32 is sufficient to claim it is also self-adjoining. So we have that it is, and hence is a projection.